area, graphics and visualization, and is now Senior Research Scientist at Intel, Bill Mark. Bill, come on up. Hey, John. So, Bill, this is our first public demo of our new baby. Maybe you can tell us a little bit about it.
Yeah, so it's a great baby. I'm really excited to be able to talk about it. So what we're showing you here is an application that demonstrates some of the flexibility of Larrabee. And it's running on the Larrabee software development vehicle. So this is the early silicon. And it's also got some other Intel goodness in it. It's got an Intel Gulftown CPU. So what I'd like to talk about is what makes Larrabee unique. Right? So what makes Larrabee unique is you get a fully programmable rendering pipeline. So this lets you, in addition to standard DirectX, OpenGL, you can also implement customized rasterization pipelines. And maybe even more interestingly, things like voxel rendering and ray tracing. So if you look up on the screen here, so this is the demo running live, and this is a ray tracing demo, right? So what we did is we took content from Splash Damage and id Software. So it's the game is called Enemy Territory Crate Wars. We took that content, the textures and geometry, pulled it out of that game, and put it into our ray tracing engine. So ray tracing is a well-known technique, but traditionally has not been used in real time. So now we've got it running in real time. And what makes it special is that it allows you to simulate the interaction of light with matter in a way that's accurate. It makes it really easy to get effects like shadows and reflection and so forth. So as an example here, if you look at the water, you see a nice reflection. And that's done with only 10 lines of shader code. It would be a lot more difficult to do in a conventional game engine. For programmers, what's interesting about Larrabee is not just the flexibility, but also the ease of development. And so let me just give you a specific example of that here. You see there's some moving objects in the scene. There's some helicopters actually temporarily to that site back. And that's traditionally difficult in a ray tracer. But what we've done here is we rebuild some of the key data structures every frame on Larrabee using a form of parallelism called task parallelism. And so what this is really showing is that you can do the same kind of things you do on a multi-core CPU, but with even more parallelism. And so very easy to use. And it's actually written in C++, and you get the standard memory model that programmers use to a cache coherent memory model. And in contrast, to do something like this on a conventional GPU would be really quite painful. Really what we're trying to do with Larrabee is keep the simple things simple. So I'm really excited with what it's going to do for real-time rendering. And it's really great to have the hardware up and running.
Great. Okay, Bill, thanks very much for our first demo.
Thank you.